Welcome to the GRAPHISOFT Open Design Collaboration presentation. In this presentation, you'll discover how architects and engineers can exchange building design information, share and manage changes, and create professional, fully integrated construction documentation. GRAPHISOFT ArchiCAD. GRAPHISOFT was founded in 1982, over 25 years ago. ArchiCAD 1.0 already implemented the virtual building concept. Today, this is known as BIM, that is, Building Information Modeling. Virtual building, or BIM projects, are better designed, more predictable to construct, and less expensive to operate. During the last 25 years, over 1 million building projects worldwide have been designed and built using ArchiCAD. GRAPHISOFT is represented worldwide, and ArchiCAD is distributed in 102 countries. It's available in 17 languages and 25 localized versions. ArchiCAD runs on both Microsoft Windows as well as Apple Macintosh operating systems. We put great effort into providing a high-end software solution for design professionals. ArchiCAD provides a fully integrated building information modeling, design evaluation, and documentation workflow. Designers using a true BIM, Building Information Modeling, software solution and workflow will need less time to complete an architectural project. The project will be more consistent than a project using 2D tools. The documentation and coordination issues become almost automatic procedures, and the overall time to market is shorter. Collaboration with engineers will be easier, smoother, and more productive. Throughout this presentation, we will focus on how designers can work together with engineers and present the design workflow between architects using GRAPHISOFT ArchiCAD and structural engineers using Revit Structure. Open BIM concept. Structural applications have at least one of the following primary functions. Modeling. Modeling applications are used to create the engineering model based on the architectural reference model. This model serves as the basis for analytical and detailing applications. Analysis. Analytical applications are used for stress displacement calculations. The results will then be used as the basis for the steel, reinforced concrete, or timber design. Detailing. Detailing applications develop reinforcement drawings and steel detailing, and they usually connect to manufacturing applications such as CNC machines. Revit Structure is an engineering modeling application that creates physical, structural, and then analysis models from the architectural input, and also has links with analysis applications via the so-called add-in applications. The integrated workflow covers the following activities. Preparation of our own model based on the fact that we would like to share an intelligent model or data with others and other software users. Filtering only the necessary or required parts or elements of our project. Exporting the filtered or entire model to others depending on the requested workflow. And the opposite direction. Supporting the import of other disciplines into our software. There are different modes of data exchange. 3D model exchange. The so-called IFC or direct model links via add-ons and add-ins developed by others for ArchiCAD and Revit Structure. 2D drawings such as DWG, and finally, documentation such as PDF, the most popular one, which can be shared and integrated easily between applications. The export and import process is repeated in additional cycles, so tracking changes between architectural or structural model versions is also very important. The reference model concept is the most important workflow concept used throughout model export, import, and change management. Each discipline is responsible for the creation and development of its own model. Reference model means that a discipline, let's say the structural engineer, uses the architectural design model for the basis of creating the structural model. The structural model will be created as a standalone model, yet some initial design information will be taken from the architectural model. Version tracking or change management can be established very well for the reference model versions of the various disciplines throughout the design workflow. The different disciplines, such as the architectural and the structural, use different design concepts and tools to create their own model. Let's look at a quick example to demonstrate the major difference between the modeling concepts of two disciplines. The architect designs a two-story column as one continuous column element in the architectural design. The structural engineer will define two separate structural column members in such a case. Both analytical and detailing applications need to consider two separate columns as well. Slabs are also handled in different manners by the disciplines. Architects typically create one single slab that spans across an entire story. Structural engineers divide the single slab into units to comply with the various structural requirements and define, for example, hollow core concrete panels. IFC is an open, intelligent, object-oriented file format. It is used industry-wide as the common platform to exchange building information modeling data between AEC applications for the entire life cycle of the building. Let's review some of the IFC benefits. IFC supports the reference model concept. IFC provides 3D geometry representation for all project elements. IFC also stores standard and custom data about each element, such as materials, profiles, functions, and so on. The applications used by the disciplines can easily and quickly filter and identify the relevant discipline-specific information from the IFC database. IFC is an open standard available freely for all software vendors. IFC is used industry-wide as the common platform to exchange building information modeling data between AEC applications for the entire life cycle of the building. GRAPHISOFT and Autodesk are members of the Building Smart Association. Both companies have already proven their commitment to open IFC-based BIM collaboration, and they both have the highest IFC certification level. Using IFC for the basis of BIM collaboration, in actuality, means that designers and engineers can collaborate safely and efficiently with other disciplines using other software. On this slide, you can see a collection of design, analytical, structural, mechanical, engineering, plumbing, and fabrication, as well as project and construction management applications that ArchiCAD and Revit Structure users can connect to via IFC or other exchange file formats. ArchiCAD Revit Structure Workflow. Before starting the applications, let us briefly overview the main steps of the GRAPHISOFT ArchiCAD and Revit Structure building design workflow. 1. Let's start with the architectural model. Architects create the first model according to the client's request in the given site. 2. To prepare the model export, architects can filter the structural elements by using element classification, layers, layer combinations, display settings, selection modes, and so on. Of course, the entire building can be exported without any filtering as well. 3. Architects export the filtered model in IFC file format. Predefined, so-called translator settings optimized for the export to Revit Structure are recommended. 4. Engineers receive the architectural model and open it as a separate Revit Structure model. Of course, more filtering can be done for the imported entire model, if it is requested. 5. Engineers link the architectural model to their structural project as a reference. 6. Engineers define the structural model and its details based on the referenced architectural model. They can also generate analytical models for analysis applications. 7. The ready structural model, or a filtered part of it, can be exported back to the architects. Engineers also use IFC file format for the model exchange. 8. There are two possible ways architects can import an IFC file. They can merge the structural model into the current architectural project, or they can open it as a separate new model. Filtering is also available for the import, and imported elements can be placed on given layers. By default, the new imported elements are protected according to the reference model concept. Architects may compare two view sets. One contains the architectural model, and the other contains the imported structural model. They can use the Trace and Reference tool to aid the comparison of the floor plan and section views. Architects can query the profiles and materials decided on by the engineers. 9. Architects can modify their project according to the imported reference model, or they can accept imported elements by using them as real ArchiCAD type elements. 10. They can export an IFC file again based on the project's new status. 11. Structural engineers can update the previously linked architectural reference inside the running structural project. 12. Engineers can make changes in the project based on the changes of the referenced architectural model. 13. And engineers send the new structural model version back to the ArchiCAD user. 14. The new IFC file received in ArchiCAD can be compared with the previous structural version. The result of the comparison is listed before merging it into the current running architectural project. 15. The comparison process automatically merges the detected changes only, so the new, modified, and deleted elements will be inserted into the architect's running project as a reference. 16. The architect can easily check the changes recommended by the structural engineer, or can make modifications to update the design manually, or by using structural elements as real ArchiCAD elements. Both engineers and architects can repeat the previously mentioned model exchange, comparisons, and updates in additional cycles. Finally, the two disciplines make their own or combined documentations. Let's see the previously described workflow in practice. We will be using a 32,150 square meter residential building complex in our presentation. Exporting the design from ArchiCAD. Let's start with the architectural design model developed in ArchiCAD. Here you can see the entire architectural model, including all the load-bearing as well as the non-load-bearing elements. Before filtering elements, we may classify them and define which ones are the load-bearing ones. Once the model classification is done, ArchiCAD can filter and display only the load-bearing structural elements with a single click. All we need to do is open the Partial Structure Display dialog to start the model filtering. We will choose the Core of Load-Bearing Elements Only option to filter all composite structures. This will hide all non-load-bearing layers of composite structures, such as insulation and mortar, and also hide all the elements that are not classified as load-bearing. The filtered model will be displayed in seconds on the screen. Now, only the building skeleton is visible, so only the load-bearing elements are displayed. The model looks fine at first sight. However, if we have a closer look, we can see that some partition walls are also displayed by mistake. Let's check the settings dialog of these partitions. With ArchiCAD's Find and Select tool, we can quickly select elements by searching for one of their common properties, such as the host layer. So, to find partition walls with a single click, we choose the partition wall layer as the selection criteria. Now, let's open the Wall Selection Settings dialog and have a closer look at the Listing and Labeling tab page. We can see that the selected wall elements are classified as load-bearing elements by their structural function. Let's modify this classification property to non-load-bearing. Please note that there are some other classification properties for building elements, such as the element position, which is set to interior for partition walls now. Closing the settings dialog refreshes the 3D view in a couple of seconds. And now everything is correct. No more partition walls are visible on the screen. Additional information, such as the function of the spaces, called zones in ArchiCAD, can also be displayed. This information will be important initial data for structural engineers when designing structural slab loads. Zones can easily be displayed in 3D view by using the Filter Elements in 3D option. Just activate zones to display them. In seconds, colored solids visualize the shape and function of 3D zones. As you can see, the architectural designer carefully specified the function of each room in the building. Checking the settings of a selected room shows its function in the zone stamp. Here we can see the function is terrace in Spanish. Before proceeding, we can select and send only certain sections of stories to the structural engineer. This complex architectural project contains 5 buildings. Now, we want to export only a particular section, the building with ID number 4 of the complex project. Let's start Find and Select again, and search for the visible elements included by the layer combination assigned to building number 4. Now, only the desired elements are selected, so we can proceed with the IFC file export. We use IFC because this is the only internationally acknowledged open BIM model file standard. Let's activate the File Save As command. Please note that ArchiCAD supports IFC, IFC XML, as well as their compressed zip file formats, which are handy in case of large projects. Now let's select the normal IFC file format supported by Revit Structure 2. Please also note the various export options. As mentioned before, we can export the selected elements only. Here, the load-bearing elements and the zones of the building number 4. The entire project, independent from the visible content of the current view used for export, or the visible elements on all stories, independent from the current selection. Now we want to export these selected elements only, so keep the first export option. ArchiCAD is shipped with numerous preset IFC templates for the most commonly used structural applications. From these translators, we will select one called Data Exchange with Revit Structure, which is optimized to exchange models with the structural engineer using Revit Structure. After entering a file name, for example architectural model, we can click the Save button to proceed. Let's send the exported IFC file to the structural expert. Importing the design to Revit Structure. Let's switch to Revit Structure and see how the architectural model can be imported to the structural project. Well, we have received the ArchiCAD model in IFC file format from the architect. Let's look at the model's contents. First, we use the standard OpenIFC command and get floor plan views by the architectural story, elevation views, and a general 3D view of the imported model as the result by default. But as you can see, some element types, such as ArchiCAD grids and zones, are missing. GRAPHISOFT developed an add-in, so-called Improve IFC Exchange, for Revit applications, that adds the missing elements and information included in the architectural model to the previously imported model status. Clicking the Add-in button, the floor plan shows the result of the improved ArchiCAD Revit connection. For example, the grids and the room functions stored in the architectural model are imported and displayed in the structural project. If we switch to 3D view, we can recognize that the 3D elements are native Revit elements. We have floors, columns, and walls. And if we check the element properties of a wall, for example, in addition to the geometry, we get the main properties of the architectural model: the structural use, load-bearing, the initial material and width suggested by the architect, the position classified as exterior in ArchiCAD, etc. Let's see an elevation view of the imported model. The import also generates the same story system defined by the architect in ArchiCAD. The imported architectural model can be used as a native Revit model and can be modified with Revit tools, or it can be linked into the structural project as a reference model for using that to create the structural model. Now we choose the second way and show the steps of creating a structural model according to the referenced architectural model. Let's save the architectural model as a Revit file called Architectural Model. Link the file into a new project where we want to create the structural model. Use the Link Revit tool and open the architectural model. Set the positioning of the model to origin to origin. Customize the display settings of the linked elements. For example, show the columns, the walls, and the floor elements only with red contours, and in halftone and transparent modes. Let's copy the columns as the initial columns of the structural model. Apply the Copy Monitor command for the linked model. At Options, we can assign the element types to the linked elements we want to copy in. For example, assign profile types available in the current project to the linked columns. Use Copy for all linked elements. Of course, we can copy elements by type. Here, we copy only the columns thanks to the selection filter. Now, the copy of the linked selected columns is displayed in black. These elements are editable elements, so they are the initial geometry of the structural model. According to the linked and copied elements derived from the ArchiCAD model, we can build up the structural model. We've already done it, starting with the structural columns, then continuing with the structural walls, and finishing the floor elements. For the columns, we decided on profiles and height different from the original architectural design. Now, we export the final model as the first structural model version in IFC file format. Name it Revit Model Version 1 and send it to the architect. If we have profiled bar elements, rooms similar to ArchiCAD zones, and Revit type grid system, and we would like to export them with the structural model, use again the GRAPHISOFT developed Improve IFC Exchange add-in to add this data and information to the IFC file previously saved by the Revit's standard IFC export. Merging the structural model to ArchiCAD. Let's switch back to ArchiCAD and merge the previously created IFC file to the architectural design. Before merging the IFC file, we should select the appropriate IFC translator. In our case, we will select the Data Exchange with Revit Structure translator from the list. Let's have a quick look at the settings of an IFC translator. At the Model Element Filter tab page, we can define what elements we wish to import or export. Now, we will import the structural elements only. We can also define certain rules for the layers. In this case, we will add the Revit Structure extension after the name of the imported layers. This will help the identifications of the imported elements. We can also convert the materials to ArchiCAD fills. All these Revit materials will be converted to their equivalent ArchiCAD fills. Also, any missing materials in the imported IFC file can be replaced with a custom ArchiCAD fill. Let's close the IFC Translator Setup dialog and merge the IFC project. Let's continue the merging process by clicking Open. The Model Filter dialog will be automatically displayed. Here we can filter the imported structural model by element type, by story system, etc. Now we will merge all building elements. Let's have a look at the results in the 3D window. Let's open the Layer Settings dialog. We will display all the architectural elements in wireframe mode and all the elements created by the structural engineer, located on locked layers with Revit Structure extension with solid colors. Please also note the imported Revit Structure elements are situated on separate layers by their type. So, merged columns, beams, and slabs are on different layers. And again, the layers are locked according to the translator settings and the reference model concept. So now, all elements imported from the model of the structural engineer are visible in solid color in the architectural environment displayed in wireframe mode. All structural components are clearly visible in ArchiCAD. Let's have a closer look at the model, which was created in Revit Structure. The material specifications are also correctly merged with the structural design. Let's select a column and open its Settings dialog. Please note that due to the previously defined material conversion, the name of the structural material corresponds to the material name defined in Revit Structure, but the cut fill of this material is changed to the ArchiCAD fill defined in the material conversion dialog. Also, we have the Revit material data for the merged slabs. Now, let's have a closer look at the columns in another view. Here, the architectural columns are displayed in shaded mode, while the structural ones are in wireframe mode. We can clearly see the difference between the two models. The structural columns differ from the original architectural ones in profile, height, and position. For example, the structural columns connect to each other, while the architectural columns are shorter because they connect to slabs, so there is a gap between neighboring columns. Architects can easily change their own elements according to structural recommendations, or can accept the structural model elements by copying them to architectural layers and using them as native ArchiCAD elements. ArchiCAD is a true BIM solution. All the design updates that you have seen on the floor plan and in the 3D view are also automatically implemented on the sections, elevations, and even in the element schedules. Let's open a cross-section of the project. We will use ArchiCAD's Virtual Trace feature to visually compare the architectural and the structural elements in this cross-section view. As we move the slider on the screen, you can see how the structural elements appear under the architectural elements in red. This way, it is really easy to identify all design changes or suggestions made by the structural engineer. Zooming in the model displays the position difference between the architectural and structural columns. Tracking changes. Let's briefly explore how architects can track changes of received structural models. Let's switch to Revit Structure first. As you remember, we have already saved the current state of the now visible structural model as the first version of the structural project and sent it to the architect. To demonstrate how structural model changes can be detected in ArchiCAD, let's make some changes in the structural model. We delete some walls here because we want to apply columns to support the floor slabs instead. We also move this column with the connected ones to support the roof slab corner. And finally, we move the copy of the selected columns to substitute the previously deleted walls. So, some walls are removed, and we have modified and new columns in this model version. We export this modified structural design in IFC format and name it Revit Model Version 2. And send the new file to the architect to detect the changes inside the architectural project with ArchiCAD. Let's switch back to ArchiCAD and compare both previously created IFC files representing different versions of the same structural model. We will do it in one single step. Let's start the Detect IFC Model Changes command. With the help of this command, we can import only the modified, deleted, or new elements from the two versions of the received IFC files. The rest of the elements will not be imported. Let's start with specifying the first version of the received structural design. Then, let's proceed and specify the second version of the structural IFC file. The next step is to filter the two IFC files. There are several filter options available. We can filter the elements by the IFC domain. For example, compare only structural or only HVAC element types. By elements type, for example, compare only columns. Or by story, for example, compare only elements of the ground floor, etc. On the next page of the wizard, we can get immediate feedback from ArchiCAD on the number of the new, modified, and deleted elements in the structural IFC files. Here we can also specify the layers, where elements imported from the older version of the IFC file should be placed. Similarly, we can specify the layers where elements from the newer version of the IFC file shall be placed. Finally, let's click the Merge button to proceed. In just a few seconds, ArchiCAD will merge only the detected changes of the received IFC model versions and display the Markup Tool palette. ArchiCAD's Markup Tool helps track and manage structural changes in the design. Let's switch again to Wireframe View in the 3D window. This will help us identify the structural elements represented with solid colors inside the architectural environment displayed in wireframe mode. As you can see, the imported structural elements are displayed in three different colors. Blue identifies the new elements. Green identifies changed elements. And red identifies deleted elements. It is immediately visible that all these red walls have been deleted by the structural engineer. In the list of markup entries, we can identify each element individually. All we need to do is click any element in the list. We can zoom in to focus on the selected element. Within the context of a large design model, this feature is extremely useful for architects. Let's select a modified entry represented by the color green in the list. A modified entry contains a pair of elements, the old and the new position or geometry of the same item. Let's zoom in and select these modified elements. They are columns. When we hover the mouse over the selected columns, ArchiCAD will display the layer of the selected element in the Info tag. The column placed on the IFC Imported Old layer represents the previous position of the column. The column placed on the IFC Imported New displays the new position of the column. Based on this information, we can decide about the next design steps. Architects can delete or merge the elements to the project model with a single mouse click. For instance, we can use the Delete Entry button to delete any markup entry from the list. The corresponding elements can also be deleted from the project model, together with the markup entry. As you can see, GRAPHISOFT ArchiCAD and Autodesk Revit Structure provide a complete, integrated, best-in-class design workflow. Together, ArchiCAD and Revit Structure bridge the different requirements of BIM models for architects and engineers, and realizes the open BIM approach for the practice, greatly broadening designers' options for real integrated project delivery. We hope that you found this presentation useful and will share the opinion of architects and engineers. Open BIM collaboration is the future of the AEC industry. The GRAPHISOFT developed add-in for Revit Structure is available from the following GRAPHISOFT Downloads website: www.graphisoft.com, Support, ArchiCAD, Downloads, Interoperability. Thank you for taking the time to watch this presentation.